Okay. So in this section, we're going to start polynomials. So we're going to go through several things. We're going to talk about what a polynomial is. So we're going to do some identifications on polynomials. We're going to talk about adding, subtracting polynomials, multiplying them, and then later factoring them, which is kind of sort of the division version, but not quite there. So your monomial is a polynomial of a particular, sorry, that's on my screen. A polynomial is a particular type of algebraic expression. A monomial is a constant or a constant times some variable or variables raised to a power that is non-negative. So what we mean is that, remember those terms we had before? So if you have just a singular term like this, that's a monomial. So it could be something like 4x cubed or negative 2x to the 7th. It could just be x by itself, or it could just be a number like 5, a constant by itself. But all of those would just be a monomial. So if I had some equation that y equals 5, well, that is one of my polynomials. It's just a monomial of 5. Or if I had y was negative 2x to the 7th, that's also just a polynomial. My click is not working. A polynomial is a monomial, or it could be a combination or a sum of different monomials. So remember, monomials are just basically like a term. So when we're talking about polynomial, it's a sum of difference of monomials or a sum of difference of terms. So once again, your polynomial could be something like x squared y to the 6th. This is just a monomial. And so is this one. But it could also be a couple monomials put together. So it could be 3x to the 4th minus 5x plus 5. Or once again, it could just be a singular number like 13. But just as long as I have some sort of summation or difference of terms, that is going to be a polynomial. Change my size here just a little bit. So we're going to talk about degree of polynomials. We're also going to first talk about what a coefficient is, or just a reminder what a coefficient is. So if I give you a polynomial like 4w squared, or a monomial, so a term of a polynomial, that 4 is what we're going to call the coefficient. The coefficient of a constant term is just going to be the constant term. So if I had 3x to the 5th, say plus 2x to the 4th minus x cubed plus 5, the coefficient of this term would just be 3. The coefficient of this term would just be 2. The coefficient of this term would just be negative 1, because we got that negative there. So we have to include that negative, and then there's that invisible 1. And then if it's just a constant term, then the coefficient, like I said, the coefficient of a constant term is just a constant. So that's the coefficient, which just be 5. We call it a coefficient because technically it does have like an x on it. It would just be x to the power of 0. So if we're doing, everything's in terms of x, well, that's actually an x to the power of 0. And like I said, this has technically an invisible 1 on it. So the degree of a term is the sum of the exponents of the variable, if there are variables. So if I had, my term was 9x to the 5th, the degree would be 5, because we have a power of 5. If I had a to the 4th be the 5th, then the degree is 9, because what we're going to do is we're going to take that 4 plus that 5, and that's how we get the 9. So it kind of comes back to what we were doing. We were talking about exponents or rules of exponents earlier. If we had the same base, then we could add those exponents. We're using that same idea. So if we don't have to have the same base, we're just saying that the degree is just a summation, like it is here, of your exponents. Okay. I can't get that quite where I wanted it. All right. Before I go into the leading term, let me just go through this again. We're going to talk about the term and then the degree. So we're going to look at each one of these. So if I have 3x to the fourth, we know that's a degree 4 term. If I have 7x squared, that is going to be a degree 2 term because I've got an exponent of 2. If I have negative 5x, recall that we have a exponent of 1. If I just write x, it's just invisible. So this is just a degree of 1. And then for just this last term of 1, once again, as that reminder, what I had written before was technically that belongs on to, it is the coefficient of x to the 0. So if we just have a constant term, then its degree is going to be 0. So your leading term of a polynomial is the term of the highest degree. So this one has the highest degree. That is my leading term. The coefficient of that leading term is going to be called your leading coefficient. So in this case, it would be that 3. The degree of the polynomial is the same degree as the leading term. So the degree of my polynomial would be 4. And this is what gets covered up a little bit on the bottom here. So we have this polynomial here. So we're saying that 3x to the fourth, like we said, as the highest degree. We saw that over here as my leading term. The 3 on it is my leading coefficient, and then the degree of the whole polynomial is 4. So we have a degree of a term, and we have a degree of a polynomial. So the degree of the term is the power of the sum of the powers in that term, where the degree of the polynomial just matches the degree of the leading term. Okay, so we want to identify the leading term, leading coefficient, and the degree of this polynomial. So we're going to write down each term. We're going to write down the degree so we can figure out which one is the leading term. So I have 5, a to the 4, and b. Once again, that b has that invisible 1 there. So if I want the degree of this term, is going to be the 4 plus the 1. So 5 b to the fourth, b, or 4, guys, again, 5 a to the fourth times b is just going to be a degree of 5 because that's the sum of my exponents. Then we have 11 a cubed b to the fourth. So we see we have a power of 2 and a power of 4, so that is going to be a degree of 6. Then we have negative 2b cubed. Well, that one's easy. We just got one exponent, so it's cubed. And then we have ab. So once again, both of those have an invisible 1 on them. So it's just a 1 plus 1, so the degree of that last term is 2. So what we see is that this has to be my leading term. That's the highest degree, so my leading term is going to be 11 a squared b to the fourth. My leading coefficient just be that 11. And it may be silly to label that. We don't seem to be doing a lot with it, but we do something with leading coefficients and your degree of your polynomial later. And then when we talk about the degree of the polynomial is going to be, because that was the degree of my highest degree here. One. So on your worksheet, just take a moment and pause this and go through this one and find your leading term, leading coefficient, and your degree. Okay, so for this one, we see that for 3x squared y cubed, the degree is going to be 5. For negative 8x squared y squared, that is going to be a degree of 4. Then for 3x, the degree is just going to be 1 because we got that invisible 1. And then for 5y to the 6th, well, the degree is 6. So in this case, this one is my leading term. So when you write that leading term, like if it's positive, then we really use it as a positive. If it's subtraction like this, we take that with it. So the leading term would be the negative 5y to the 6th. Leading coefficient would have to be the negative 5. And then once again, we know that the degree of the polynomial has to match the highest degree, so it's going to be a degree 6. So like I said, each term can have its own degree. What we're really interested in the end, though, is the degree of the polynomial. Because later what we see is your highest degree is going to have an overall trend of how your polynomial is going to act in the long run. Okay. So another part of this that we care about with the terms is ordering. So we generally arrange polynomials, sorry, we generally arrange polynomials in descending order of powers. Sometimes we do ascending, but it's usually going to be descending. So it means that we want to start with the highest power first. So if we have this here, 4x plus 5x squared plus 1 plus 7x to the 7th, then if we want it in descending order of powers, then it was going to be, this is my highest power, so 7, so I write 7x to the 7th, and this is my next highest, so minus 5x squared. My next largest power is that x of 1, so 4x, and then 1. So if I wanted to do instead ascending powers, all we do is ascending orders. I'd actually just flip this around. So this is my first one, and then I go up to the next highest powered term, next highest powered term, and the next highest powered term. So like I said, we prefer descending order. This is the one that we're going to prefer, but you may be asked to do ascending order at some times. We're going to get a lot of practice with doing this because when we start dealing with polynomials much more as we go a little further along, we're going to really pretty often make sure that we have the powers in ascend or descending order just to make some things easier for us to handle. So we are going to consider the polynomial. So this case, I have 2 variables. So I'm going to arrange it in descending powers of x, then ascending powers of x. So we're not doing it by degree, we're doing it by one variable. So if I'm just doing descending powers of x, even though I have a y, we're not looking at that. So oftentimes when we have polynomials with multiple variables, we will decide to arrange it by just one of the variables. We're gonna have descending powers of x and then ascending. So if I'm doing descending powers, my smallest power would actually be this one because I don't have an x on it. So that would be the first one. Then the next highest power for x, and I circled the wrong thing over here. I think I just missed it. There we go. Then the next highest one would be this one because we have x to the power of 1. A second. I'm doing ascending powers here. 3 is my smallest, and then the next one is 8xy squared. Then my next largest power would be this right here because now we go x. I don't have an x squared, but I have an x to the third. So I go 4, negative 4x cubed. Then the next one is this x to the fourth, so plus 2x to the fourth y. And then my last one is just x to the fifth. Now, if I want to do descending powers, I just write these all backwards. My highest power with x to the fifth, then my next with x to the fourth, so I have 2x to the fourth y. And then my next highest with x to the third, so minus 4x cubed. And then we have an x squared, my next highest. So, or sorry, my x, we don't have an x squared, my x is, so 8xy squared, and then my constant is the last one. Okay, so consider this polynomial here, the one we just had a little while ago. We want to arrange it in ascending powers of x as best you can. As you can see, there's a little problem in here somewhere. We're going to see how you kind of handle it. Okay, so we're talking about descending powers or ascending powers of x. So if you do ascending first, then my smallest power of x, and actually it's going to be this term because there's no x in it. So it would start with the minus a 5 y to the 6th. Well, then the next one we have is that 3, or 3x, so we put plus 3x. Then you may have noticed we had these two that have the same power of x. So the suggestion would be, at that point, if you're trying to think how to arrange them, you might want to go by degree. And since we're going up, we might want to do this one first, because it's a smaller degree than the other one. Had you written these two in a different order, that would have been fine, because all I asked you was to write in ascending or ascending powers of x. Those would also didn't get as valid. Just suggesting that, if you're told how to order something by powers and you're getting stuck in a situation by that, you might want to start ordering by degree, because the power on x's are the same, but the degrees are not. If I do descending, then descending means I just need to flip around, so I need my highest first. Then my next highest. Then my next highest, and then my next one. Or could have wrote the negative 8x squared y squared first, because all I asked was order of powers of x. So the top ones are probably what's preferred, but if you did either, that was fine.